Ooh.
That's the key, because you don't want to forget that. That's happened to me before, I will admit. All right, so now we're just waiting for people to come in, but we still have like another minute or so. This is when I always have, and the recording will show for the record's sake, panic, where I think, my God, maybe the link was wrong. Something happened. The link must have been wrong. And I'll go through a little bit of abject terror until I see the participant count grow, just like it did right now. So nice. I did it right. Also, I mean, let's be honest, I triple check it because, but still I go through the panic, which helps me be inspired to triple check it on the next event. So what's your crazy process before you start your events, guys?
Not too much. You got it pretty dialed, but well, you know, we've been using StreamYard for our live streams, and it's been really not working at all with LinkedIn. And so that's been like last week we had it set up a scheduled event on StreamYard with LinkedIn, and it did not work at all. It fucking sucked. So yeah. So I had to basically like, I realized if we just tried it out, just set it up right before the event starts. But what that means is your promotion totally is non-existent. So yeah, that's been a rude awakening, but we make it work.
Yeah. That's where it comes from.
Yeah.
Okay. Well, people are coming in. So to everybody that is joining us, thank you so much Matt, for being here.
You're
just... muted. He's muted.
Is your name spelled Housley?
Yeah. Oh, sorry. It should be L-E-Y on
there. Did I do that wrong? I think, that would, I will take ownership of that.
No, it happens all the time.
Thank you for that. And we're going to squash it right back.
When I first met Matt, I always used to do that too. It's like, how? Sorry. Why would you spell it another way?
I know. Yeah. It's obscure enough.
What's wrong with you?
Man.
Yeah.
Is that how you spell house?
Well, I am so sorry. I'm so sorry.
It's fine.
Don't worry about it.
It's okay.
Spelling issues, full ownership. Working on that. Okay, so let's just go ahead and get everything kicked off. I want to welcome everybody. Thank you so much for joining us today. My name is Kayla Garrido, and I head up marketing and events here at Great Data Minds. GDM is a collective of passionate data activists, and we're on a mission to modernize the world of data. So we do this in two ways. The first is through a full range of services for strategic planning, education, the deployment of critical data projects. And then the second is through creating all of this great data-related content, just like the event that we're here to do today. So please check us out at our newly redesigned, looking fresh, but still working out a couple kinks website, greatdataminds.com. We're in the regression testing phase of that, so you know we're getting there. All right, everybody. So this is a webinar, and I know after all these Zoom calls, everybody knows what that means. Your cameras and your microphones are off. But we will be manning the Q&A and the chat, which I see is already getting going, and we encourage participation. We'll reserve a little bit of time at the end of the session for a more formal Q&A. So today we are gathered here to talk about data engineering, the ins and outs, and we have the experts that are going to weigh in. Allow me to introduce the co-founders of Ternary Data. We will start with Joe Reis, whose name I can spell. Joe is a recovering data scientist, and he is the CEO at Ternary. He's a business-minded data nerd who has worked in the data industry for 20 years doing statistical modeling, forecasting, machine learning, data engineering, data architecture, and everything else in between, though that did sound like a pretty comprehensive list. And then we have Matthew Housley. He is a fellow recovering data scientist, and he's also a reformed academic holding a PhD in math and a dual master's degree in both math and physics. I'm always a little intimidated by your education. I do want to admit that, Matt. I always feel that when I read your bio, I'm like, whoa, rocking my bachelor's degree.
Same.
Right.
You guys are just fine. Like
we're doing okay, but we need the Matts around too. So he started his career as a professor of mathematics before he joined one of the largest e-commerce companies as a data scientist. And together, these gentlemen are doing some great work with their consultancy. Plus, they are running the Monday morning data chat podcast, which is very great and very consistent. I always see that on Monday mornings, so that's awesome. And in addition to all that, they're wrapping up their first O'Reilly book, which is the fundamentals of data engineering, and that will be due out towards the end of this year. It's quite a rap sheet, guys. Quite a rap sheet. Thank you for being here with us. And then to introduce my colleague, of course, we have Mike Lampa from the Great Data Mind side of the house. He's our Chief Analytics Officer. Mike has just a whole career's worth of experience as an executive analytics practitioner, both as a consultant and as an employee in Global 100 companies. And I will pass the floor to you, Mike, to take it away.
Thank you, Dahlia. Gentlemen, how are you today?
Good. How are you?
Peachy. All right, I have an opening question.
Okay.
How do I know that I'm at the tipping point of becoming a recovering data scientist?
Matt, you want to take that one?
Yeah, I'll start. I mean, I think in practice, a lot of data scientists have this experience and they either run the other way, which is actually not an unreasonable response, or they embrace it. And so if you embrace it, what happens is you start working on your laptop, you start building some models, but then you discover that like you don't have data pipelines to do your job efficiently.
Or data. And so you start getting pulled into that side of the house and then gradually like, actually, this is really interesting work. It's critical. So I'll work on this. And then eventually you just end up being a data engineer, which in some cases is also a recovery data scientist. Yeah, I think it's born from the, you know, you'll meet some data scientists and analysts increasingly that are maybe disillusioned with their ability to do the job they're hired for, right? So you're told, oh yeah, you'll be able to do like model building and all the fun data stuff that you think you're going to be doing. Then, you know, when you're 12 hours into doing janitorial work on data, you know, I think it's a bit illuminating. You know,
disillusioning.
It is for a lot of people, yeah. And so I think Matt and I, we jokingly call ourselves recovering data scientists, but I think it's actually quite a bit of truth to this statement.
Well, and this feels like a nice, you know, kind of a segue into the three themes that you want to share with us today around for the data engineers to take heart.
Yeah, let's talk about that.
Yeah, let's get into them. What's our not necessarily ordinal in importance, but what would be the first one of those three themes that you want to share?
Yeah, I think the first one is, you know, it's happening across the board in data, but it's becoming a lot more, the tools are getting simpler, right? And so I would say there's better practices as well. So whereas back in the day, a data engineer would focus on, you know, maybe setting up Hadoop and maintaining that kind of a stack, it's just not necessary these days. I mean, if you're doing that, I guess more power to you. Don't think you need to do that these days, depending on your use case. And so I think a reduction in complexity and increasing abstraction and tooling is going to lead to a bigger focus on stuff like the data lifecycle, for example, right? I think that's a really big one. Matt, you want to explain the data lifecycle?
Yeah, and we call this in particular the data engineering lifecycle because we've kind of tailored it very specifically to data engineering applications, but I think analysts and data scientists and other data consumers should be aware of it as well because it kind of underpins everything that they're going to do with data. So first of all, you have ingestion. So how much time do data engineers spend on ingestion? Still quite a bit. I think there's a really nice suite of tools that help with ingestion now, but what happens is data engineers have to focus on the edge cases where those tools aren't available. Next thing, and this is not strictly like sequential, but next thing we talk about storage. And if you think about like the big developments in data engineering, like Hadoop, what was Hadoop fundamentally? It was a storage system that you could build processing on top of. And so you have to have a strategy for storing your data that will also lend itself to all the other stages of the life cycle. Then we talk about transformation. So what are you actually going to do with the data that's interesting to make it useful to data scientists, for example? And then the last part is serving. Serving is the last stage, but we actually think it should be kind of top of mind in all the other stages. The whole point is to motivate all the work of data engineering by how that data is going to be consumed and used. And I think in the kind of peak big data era, that was one of the reasons that some of these projects failed because there was such a technology focus. People would focus on like, how much data can I bring into my system without thinking about how it was going to be served, how it was going to be used, who their consumers were, who their stakeholders were. And Joe, I'll let you follow on to that.
I mean, yeah, I completely agree. Yeah, life cycle is big, and it's focusing on outcomes. I guess the old Stephen Covey quote, like, begin with the end in mind,
Right.
definitely holds true, and it should always have held true, right? I mean, we've all been in data for a while, but it's easy to become enamored with the latest gadgets and gee whiz stuff. I mean, that's really cool, and because you have the word engineer in your title too, the temptation is to engineer all things.
Mm-hmm.
So yeah.
I've been inside of companies as a consultant and, as Kalia mentioned, as an employee. And so many times I had to undo we're going to build the data and then they'll come. Especially the last instance where the director of data engineering, if you will, data warehousing, decided he was just going to drop everything he could find into Hadoop. And, it was a disaster because, well, to your point around build with the end in mind, you have to really understand those use cases you're going to be enabling so you can organize your data products appropriately.
For sure.
Yeah.
I think, one thing we encourage engineers to do is, work on the other side of the fence. By that meaning like, if you come from a data science background or an analytics background, I think it actually helps you to a large degree if you become a data engineer, because you really understand what the product should look like.
Mm-hmm.
I know some people that say, oh, data scientists can't become data engineers because they don't know how to code. And I think, well, Matt and we're data scientists, and but we also know how to code.
Right.
But the whole point is, it, especially with tooling becoming more simple, like the ability to code, you're going to be coding more for the right reasons and not just coding systems just because that's what's required. So, this morning, my team and I were setting up like Fivetran into BigQuery, right? I still consider that part of the data engineering lifecycle. It's data ingestion, storing data, and then querying it, but transforming it. But that's not. But I don't know how much systems integration was involved. I mean, Fivetran did all that behind the scenes. People still coded it, but we didn't have to. But it doesn't make me any less of a man for not not doing that. So, what's that?
I'm sorry. Go ahead. Good.
Oh no, go. What were you gonna say?
One more question around the data lifecycle. What about, does it go all the way to the recognizing you should be decommissioning some of these data products, either because they're obsolete or stale or dormant?
Yeah, I completely agree with that, because what happens is if a data engineering team is focused on some data product that's not actually being consumed, even if kind of in the back of their minds, they know it's no longer useful, they're still going to get alerts. They're still going to have to invest effort into maintaining that. So yeah, deprecation, decommissioning is very helpful in terms of focusing on the things that are actually a priority. And I think dev teams understand this too, right? If you've got dead code floating around that's generating build problems and test problems, then you're going to be focusing on that instead of your new features.
But it's always sort of the balance, right? Because you want to, having legacy is fine, I suppose. As Matt and I always joke, like, legacy is a condescending term for stuff that makes money.
Yes.
So
I love that.
So, you don't want to kill things just because it's old, but you want to kill things that are useless. So, but old and useless are sometimes used in the same phrase, in the same sentences. And I think that's sort of the misnomer, because again, engineers, I mean, there's a tendency that want to do like data, resume driven development, for example, right? Where you're just constantly focused on, well, what's going to get me my next job somewhere else? Obviously not the stack I'm working on. So, if I can work on the cool new stuff, then that would, look more favorably, and then I'll have friends and, date lots of people, and life will be great. So,
right.
Yeah, but
right.
Yeah, but I think life cycle is a really big one. And again, it shouldn't be such a revolutionary concept, except for the fact that it when you mention it to people that I think they're kind of shocked, because it's one of those things that's kind of like air, like you exist within the data lifecycle, whether you recognize it or not. But most people, I think, are seemingly unaware of its existence. The focus on maybe one aspect of it, but not thinking holistically. And I think increasingly, thinking holistically is going to be much more front and center in data engineering. So
yeah, I'm finding as well. I made mention of the term data products, treating your data as an asset, and I still get a lot of people kind of looking at me, the cocked head. What are you talking about? But I'm trying to help people understand that we're building product that's going to enable value. I think for the most part, the value is going to be generated by the end state, which you said, design with the end in mind. But we have to start treating those data assets because they're going to start becoming part of the balance sheet and part of the valuation process of organizations.
Absolutely.
All right. So now we understand the darn life cycle out there, folks. Let's talk about another theme, gentlemen.
Yeah, I mean, actually, what you said is a good segue into the next one. I think, Matt, and I think data practices are going to become much more enterprisey. Enterprisey in quotes. But what does this mean? I mean, the term enterprise really, I think, triggers people, right? Because you either think of, in a lot of cases, it's like, okay, so blue shirt and khakis, stale, boring, no innovation, yada, yada, yada. But what we mean by enterprise are all the things that, maybe big enterprises were doing with their data and data products for the longest time, things like governance, quality, data ops, and so forth. And increasingly, these same practices and tools are available to small startups and kind of everyone in between. So, the barriers to entry are insanely low right now. And the other day, I was talking to a data catalog company that, mainly focuses on startups. It's a SaaS company. I was like, this is cool. It's awesome. So,
but gosh, as you can tell, I've been in the industry for a little while. If I could have had some of these tools back when I was the data architect, driving out the target data models and writing up all the mapping specs. Oh gosh, so much more we could have gotten done.
Oh yeah, that'd be great. Yeah, data management is another one. I noticed there's a question here. I don't know how you want to handle the questions, but somebody's asking about data management. And data management is actually one of the undercurrents of what we consider one of the undercurrents of the data engineering life cycle, right? So, but data management is such I think, an all-encompassing term too. If you go back to the DMBOK, the Data Management Book of Knowledge, it's a 600-page committee-written book that basically I felt like it was a grab bag of, it's also include that in data management as well. But we do consider that to be one of the undercurrents. And by data management, I think what we mean is the management of data. I know that's like kind of a stupid way of expressing it, but it does encompass, I think, a lot of things like quality, governance, and so forth, right? So, but again, it's ignored a ton. What do you think, Matt?
Well, especially in the kind of peak big data era, there was this attitude that data management was like for stodgy old enterprises that weren't innovating. And then what happened is these, tech companies that were doing bleeding edge things started to mature and realized that they had a huge mess, that their data was it was completely disorganized. They didn't fundamentally have a purpose for serving it or data quality processes in place. And I think now that the tools have matured more, now that it's very easy to spin up like a cloud data warehouse or a Spark cluster, there's now a shift to saying, okay, data engineering also encompasses things like making sure the data is of good quality, that we can actually find out where it is, data cataloging, that we can see where it came from, data lineage, all these like things that used to be considered stodgy are actually very, very high value and very important to the role of data engineering.
Yeah, it's weird. Like a lot of people we talk to, which is a lot of people at this point, but yeah, it's weird. Like all these things that were kind of written off, like, oh yeah, we don't do that's boring. Now everyone's talking about it. Data observability is a really big one that everybody's in data observability right now. I mean, I can probably walk down the street and my 80-year-old neighbor, she's probably got a data observability company too. It's like everyone's got a data observability company, or data catalog company or something. So it's hot. It's a hot space. I think it's cool.
So I'm glad you brought up data observability because I'm seeing a lot of rhetoric on it. Is that a component? Let's talk about data ops a little bit and help you understand if observability is part of the ops mantra.
Yeah. I guess it depends. There's an official data ops manifesto, right? Is data observability in that list? I think it is, but
the concept of observability is in it. Yeah,
exactly. But even if you don't subscribe to that particular list, I think it needs to be a core part of data ops for everyone. And actually, Raj's other question was about burnout. I think let's loop back to that in a second when it comes to data ops and observability, because I think that's a closely related question. But
But I mean, if you go back to the history of DevOps, though, right? I mean, if the DevOps handbook, it was written, I think, 2009 or something. I mean, that basically data observability is just applying those same principles to data. What are those principles? Well, observing and monitoring, incident response, those sorts of things, right? Things that are traditionally done by software engineering teams that are now, increasingly being, at least I wouldn't say done, but at least I think more people are paying attention and knowing they need to incorporate these practices. What we find interesting is data really seems to be taking a lot of practices just from software engineering, right? Whether you're talking about, it's clearly inspiring. Yeah. Like observability being the big one. I mean, how many data observability companies talk about how they would like to be the data dog of data, right? Like every one of them. And it's always their pitch. I go to all their sites. It's like, oh, we're the data dog for data. And I'm like, you should find a new tagline. So
what is data observability? Help the folks understand. I have some ideas in mind, but I'm interviewing you, and I want to hear your point of view.
Yeah, no, again, it's really the ability to observe, monitor, and respond to incidents that occur within your data pipelines, as well as data quality issues. And so it's really, one is knowing what's going on, and two is being able to respond when incidents do occur. And I think that's really the essence of observability. Bar Moses, she calls it, data reliability or data health. I think that those are two really good ways of expressing it. I think Igor from Big Eye also, has this notion of like data reliability, or the concept of a data reliability engineer. Like that's a new title that really just basically means like you're just making sure the systems and the data itself are reliable for downstream processes. What do you think it is, Mike?
Well, a couple of things. The embedded test harnesses in our data pipelines, I think, are incredibly important in production. This isn't a development concept. We got to put those things in production so that we can track any kind of drift or any kind of anomaly, unreasonableness, unreasonable flows of data. It was like, by running some statistical process control checks, it's like, why did I all of a sudden go 6 deltas out of norm, right? And then the other element, I believe, observability extends into the machine learning apps as well, because I have to monitor the drift of the data feeding those models. I have to monitor the drift of the efficacy of the models, right? So I see it really as a great opportunity for people to be embedding everything you need so that you know about your data issues before your consumers know about it.
Yeah, that's exactly right. And you bring up an interesting point too. I mean, there's a kind of a third wheel. You got DevOps, data ops, now you have ML ops, and so, and then, and when you look at the ML ops space too, what I find interesting is there's definitely some subtle differences between what data ops is doing and what ML ops is doing. For example, as you point out, like model drift and so forth. But really, when you kind of dig under the hood, it's all tracking basically the same stuff. And so what I think, and this will get into our next point here, but what I think we foresee happening is, I think over the next several years, you're going to see sort of a melding, a fusion, so to speak, of software engineering, data engineering, and machine learning engineering. Because as basically, and we can get into the third theme here, which is fast data. As data starts moving more quickly, as you start having like streaming first is more of the rule and not the exception. What that means is a tighter feedback loop between all of your systems, and the life cycle. Even zooming out from the data engineering life cycle, just the data life cycle itself becomes very continuous, almost like a tornado in that sense. And so, what we're predicting is going to happen is basically, moving beyond a couple of things really. Data is obviously moving, towards real time. What this means is we think the modern data stack that gets supplanted by what we're calling the live data stack. What the live data stack really is, again, it's a fusion of bringing, I think, breaking down the silos between application data and machine learning, and really everything flows in a very harmonious cycle, because they're, as you point out, people are making data products, and another term that's being thrown around is data applications. These are fundamentally different than internal BI. Now you're talking about external facing products that real customers use. Examples might be Google or Uber, which everyone uses, right? But those are basically just very big data products where the walls between software engineering and machine learning, or it's very blurry, because machine learning powers that product. And so what we see happening is that's going to become front and center. We can talk more about what the implications of that is. But
yeah, and I think the flow is not unidirectional anymore either, to your point. As that line blurs, the feedback loops are happening all over the place too.
Yeah. It certainly is. And so I mean, so we have the notion of like the data engineering lifecycle, but as we point out, in the book, it's a lot of these stages could be sort of intermixed, or there might be feedback loops within these stages. Because and then, the introduction of reverse ETL, I think, means it goes back to the application, but we just see that more as a sort of a bridge to probably something much more interesting going forward. Like we're fully thinking that, there could be a case to be made where a lot of the data engineering we do right now should be done at the application layer. Mm-hmm. And you're basically just making data intensive applications versus sort of having this weird intermediary called the data warehouse in the middle of things. Like why, if everything's moving fast, like why do you need this sort of like, this bottleneck here? Mm-hmm. So I'm not saying it won't go away, but it might just be one component of a much bigger data stack that's yet to be made. So
yeah, I wonder if the data warehouse is, I don't foresee it going away, but I wonder if it's not going to be this ubiquitous single vehicle for enabling analytics, especially as we get into more embedded machine learning based algorithms running in the business processes where they're just doing an invocation of the model and then returning the payload and getting the result, persisted back.
Yeah, I mean, fundamentally, there's still going to be a difference between transactional systems that support applications and analytics. But I think instead of having like a very discrete cutoff, throw it over the fence kind of mentality, where application development does its own thing and then just kind of tosses the data over to ETL developers, data engineers, say, do what you want with that. You're going to think of these more as just separate layers. So you've got kind of your application transactional layer, and then maybe you have a streaming pipeline, Kafka, Google Cloud PubSub, something like this in the middle. And then you have your analytics layer. And in many cases, in a data app, in like a SaaS product, users are going to be able to see analytics in near real time with potentially vast amounts of data if they're handling large amounts of data with that SaaS product. And we get requests more and more for these types of data applications. And I think the tools are out there to do this, but the paradigms still need a bit of
it's very immature still. Yeah. Because what we're seeing, the classic data warehouses, I mean, I think they're really good at what they're meant for, which is, BI and that type of stuff, historical facing analytics and large amounts of data. But, as I've been writing this week, though, I kind of question, some aspects of BI as well. What's the intent of doing BI, right? I mean, you're trying to take an action, you're trying to get actionable insights. But if you have fast moving data, at some point, why don't you just automate the actions you're going to take? So it kind of makes me wonder, what the future of analytics also looks like. There's a whole field like analytics engineering, for example, which is really cool. And I think it's opened up data to, a lot of people who are, I think, underserved, mainly analysts. I think that's awesome. But I can't, I've been in data and you've been in data long enough. You can't just say, oh, that this is actually, this is all that's going to be done from here to kingdom come, right? Like it feels like we're at the beginning of really utilizing data to its fullest potential. And I think it feels like it's just getting started more than anything. So
yeah, which is insane because how long have we been building balanced scorecards and dashboards and, whatever, non-actionable visualizations.
That's really interesting. Non-actionable visualizations. Yeah.
It's like, pretty as all get out, but it's like, what is this telling me?
Right.
Is that number good? Should I be worried about it? Yeah, it's insane.
That's really interesting. Well, I mean, on that note, though, it's interesting. I had a really good conversation with Ollie Hughes from Count.co, and he brought up a really good point. Like he analyzed how people make decisions in their companies, and it was really analytics. BI analytics is really it's more used to sort of chase the status quo. But he said the only time you really start making a decision from data is when there's been an inflection point in your business, right? That forces you to reevaluate stuff. Because otherwise you're just trying to make sure things aren't changing, but that's not really a decision per se, right? It's more babysitting.
Yeah.
So that was an interesting insight, but
thank you.
No.
Elliot, give me a gold coin for that one. All right. Let's talk a little bit more about fast data. We started talking on it, but I want to finish. What do we mean there, right?
Hey, Matt, you want to take that?
Yeah. I think one of the big ideas here is that there's a lot of confusion about what fast data even is. And frankly, some of this is kind of the vendor's fault because they all talk about how fast their product is without explaining what it does well and maybe what it doesn't do so well. So when we talk about real time, what we're talking about is latency. So in other words, the gap between something happening in the real world, where the real world can be a website or something, someone clicks on a link, for example, someone sends an email, and then actually seeing that show up in a report. So true real-time systems, you're talking seconds. Something can happen, an event gets pushed to a streaming pipeline, and then you can consume it within seconds. The second type of performance is query latency. So how quickly can that query run? I hit enter, select whatever, and I get back a result within, sub-second in some cases. And so both of those capabilities are extremely valuable. It's just important that data engineers know how to explain the use cases for each, explain tools that do one or the other or both well, essentially. Yeah.
Mm-hmm.
And then what about the concept of, like event-based triggers or, the processing of change data?
Yeah, so I think
follow in the fast data as well.
It definitely does. So you've got a couple of approaches to low latency data. So in other words, when I have an event-based pipeline and I can see things happening within seconds, there's sort of the traditional approach, and so where you can just run a SQL query on top of that data, get statistics based on a SQL query. The other type of, I feel like there should be a better, maybe a trigger is the right term for this, but I feel like someone needs to coin a better term where it's
not a database trigger. Yeah,
it's like a database trigger. Right. Yeah, it's like a response to actual data arriving.
Yeah,
exactly.
Yeah, sensing
sensing.
Yeah,
maybe it's sensing. I mean, maybe that's what it is. But like, for example, you can have a system like Apache Flink where it sees data coming in and then it just triggers off of certain types of events or certain statistics happening, where it tracks a window of data for like 2 minutes worth of data and it says, hey, if this metric goes out of this bound, then I'm going to send an alert. And so this goes back to like automated decision making, like Joe was saying. You can have a system look at like website performance, for example, track it over a 2-minute window dynamically, and when certain metrics, say your website gets too slow within that 2-minute window, someone gets an alert, or there's some kind of automation that happens.
Yeah, and then the other type of event would be like change data capture, right? So that's traditionally looking at database logs, for example, and tracking changes in the state of the data. So, CRUD operations, create, read, update, delete type operations that occur on the data sets within a table or a database or a schema and so forth. And that's very common too, right? So Fivetran does this really well. HVR does this really well at higher volumes. I think, that's what's popular right now too. We see a lot of change data capture happening, and which is nice because back in the day, and people still do this a ton, maybe it's just so an important point in time data retrieval, batch oriented. So I'm just going to get it from like midnight of, whenever to midnight of whenever else. And so that's very common. But if you had the choice of just getting data, as it arrives and changes, I would think you'd want to maybe go with that. But
yeah, just let it flow. Gosh,
let it flow.
I can remember how many hours we spent designing CDC pipelines back in the old days.
Wow.
Literally, figuring out all the patterns and doing things like calculating a hash total on each row to see if something changed, because I had no timestamps and stuff like that.
Oh, wow. Crazy.
Yeah, see, I'm telling you, I'm pretty old.
What's funny, about that is we set up Fivetran and it got working in 3 minutes.
Right.
And,
and the other thing that's intriguing the heck out of me, I love, is change structure capture and how elegantly some of these products are handling a new column showing up or an old column going away. And I don't have to worry about it breaking pipelines anymore.
Right. Yeah, that was a big problem.
Yep. It's all the downstream stuff you didn't have to worry about. But I think we're coming up with ways of accommodating that, right? Dynamic schema changes and such. It's a new world.
Pretty cool. Yeah.
Yeah.
Well, look, we do have a couple questions. You guys want to entertain them?
Yeah, sure.
Yeah. I think go back to Raj's question about.
We kind of touched on Raj's. Let's finish it up. Yeah. So how is data management at large aligned or not aligned to the role of a data engineer?
Yeah, and I think it's a core part of the role now. In our book, we're going to talk about various types of management structures that you can use. I think in general, there's a move toward decentralization with accountability. So in other words, part of the reason that data management had such a bad reputation is that it was like a committee process.
Mm-hmm.
So you have a committee that would get together to make decisions, and that this was horrible. Like if you wanted to make a change in some table, it could take months and months to get that approved.
Well, in terms of governance too, right? Like that scares people away. It's like, I don't want to deal with these guys. You guys suck.
Yeah, that's right. Like the governance, it was the governance police. Whereas now I think the decentralization is that data engineers are involved in the process. Even analysts and data scientists are involved in processes of data governance, data documentation, lineage, making sure that data is of high quality. And so yeah, data engineers in this more decentralized vision are right in the middle of data management.
How does that fit in with data mesh, Matt?
That is a very good question. Joe wants to make this call controversial.
We're going to talk about vaccines next. So
data mesh is kind of a different, it's an extension of the notion of a cross-functional team. So when we talk about various ways of organizing data engineering, one way to do it that's very common, that can still involve some decentralization, but you have a centralized organization that's a service organization, and it's responsible for serving a lot of different data needs. Expanding the cross-functional team concept that's become popularized on the app side. The idea with data mesh is that not only do you have like a DBA, DevOps engineer who works in the cloud, application developers, product managers working on one team, you can also have a data engineer in the mix that handles analytics data for that team and is responsible for serving it to the rest of the company. And so they are also presumably going to be responsible for data management for that team. So data quality, data lineage, all these core competencies. Yeah, Joe, go ahead. You look like.
Well, no, that's good.
Okay.
Yeah, but I mean, in the article that Zhamak, the second version of the data mesh too, it was, there's definitely an underlying sort of cross-sectional governance layer, right? Federated governance and so forth. So, which depending on the type of company you're at will work or it won't, right? Because I think we've all seen, if your company's really siloed, I just, cross-sectional data management would be very interesting to see on work. So
yeah, the work we've done so far, we're seeing, I mean, there are use cases where leveraging a mesh approach and mesh technologies will close a gap, but it's not a one size fit all, just like nothing else is.
Right, for sure.
I have a follow-on question on the data engineer themselves. Are you seeing more data engineers also have the data architecture, data modeling skill set?
Yeah, data architecture is another undercurrent of the life cycle that we've identified. We think that even though if there are data architects at a company, data engineers should still have basic architectural skills, right? So knowing how to architect scalable, reliable systems, for example. But we define architecture as really understanding trade-offs, right? As Neil Ford says, there's no great architectures. There's only like the best worst architecture or something like that. So
least worst, yeah.
Least worst, yeah. And I think that that's really apt. So you really need to understand what your requirements are. What's available to you to solve those requirements.
Yeah.
But as you say, it's not a one size fits all. But architecture is definitely front and center. Especially as we identified earlier, with the live data stack. Potentially supplanting the modern data stack at some point. This is understanding the architectural components of real time, for example, or batch, and everything else in between is incredibly important. So,
well, thank you for bringing that up because I'm worried about the importance of the architecture going away.
No, it's incredibly important. We think it's going to come back. And you mentioned modeling too. We've actually been thinking a lot about this. Modeling is one of those things where I think that it's, and Matt can touch on this too. He's got some great opinions, but the modeling, I think it's becoming a lost art in some ways, right? So, you had Inman, Kimball, Data Vault, and some other approaches, Beam, which is sort of a, kind of a runoff of what Kimball was doing. But at the end of the day, what is happening is, denormalization, wide tables is like sort of the antithesis. We see quite a few data engineers just going that way. Some are doing more kind of ad hoc modeling and so forth. At the same time, what you're starting to see is like the semantic layer popping up. So DBT just announced their semantic layer, I think maybe yesterday or very recently. There's a big push in that. So that we find that very interesting, but it's kind of a step towards not really modeling, I would say, but more, more modeling, maybe definitions of like attributes or functions, but maybe not a comprehensive model like you would with Kimball, for example. But what we're really excited about is there hasn't been a real change in modeling for like 20, 30 years almost.
Yeah, some of those, well, several of the principles still hold true, even though the technologies have, I will admit, the technologies have enabled me to not over-engineer my data model.
For sure, yeah. And we think modeling is insanely important. But what's going to happen so the question we have is, okay, so with fast data, right? Some of these things won't work. Like Kimball won't work with streaming data. It can't. And so what's next? What's the next data modeling? This is something that Matt and I have been nerding out on a ton, especially as you start getting, so we think things like metrics layers are in the wrong spot. It's at the data warehouse level. What we're trying to think of is, okay, so what happens when the application is the one generating the data? Why aren't you doing all your modeling up there if that's generating the data for all these streams anyway? So this is it's fundamentally shifting the location of modeling as well as the practice of it. When we talk to people who are, involved in streaming companies, for example, or making streaming databases, we've asked some of the leaders in this industry, like, what do you think about modeling? And they're like, just don't do it. Just assume the application's correct. I'm like, I can't take that as an acceptable answer at face value, right?
Well, and what happens is we end up all the consuming BI clients, right? All have a semantic layer, so we do our modeling in the semantic layer.
Right.
But if I have five BI tools in my organization, which most do, I'm doing it 5 times.
Exactly. And the lean process junkie in me, which I used to be a hardcore adherent to that stuff, that drives me insane, because I look at the whole value stream, like it's in the wrong spot. Like it's literally it's literally backwards. So we think modeling is one of the most underrated skills, and we call this out quite often in the book. Like it's definitely one of those things where there's practices we encourage data engineers to adopt. Definitely the batch practices. As streaming becomes front and center, we're doing a lot of thinking on that, because there really isn't a modeling technique for streaming right now. Data Vault sort of solves this. Data Vault was made for it, but at the same time, tell me how many Data Vault implementations you've seen in the real world.
I've seen a few.
Right.
I dabbled in one. My one observation was I created a lot more tables.
Yeah, exactly.
Then I had to turn around and bring them back into a star anyway, because that's what the BI.
That's exactly what, it's just a lot of work. So in the book, I have it upstairs, the Dan Lidster book, it's like 600 pages. And I'm like, I mean, it's, I think it's a great concept, but it's definitely, it's hard to implement for a lot of companies. And we see the same thing. We talk to people and it's like, we tried it, it's hard, but if you want to do it, go for it. Yeah. What are some other questions?
Raj has a great comment here.
We're getting a lot of observations.
Yeah.
Go ahead, Matt.
So Raj just posted a great comment in the channel here. He said, with fast data, we still have to model event-based modeling. Exactly. And that's kind of what we're thinking. Like, I think part of what happened and part of what's blown up this whole space in a negative way is that when NoSQL became so popular, a lot of people interpreted that as no schema. And that was, anyone who's dealt with that kind of a toxic waste dump knows it's a nightmare, where developers are just willy-nilly creating new fields all the time.
Well, what do we see? Well, we saw one thing where somebody had a date as a key, like a timestamp.
Yeah,
there you go.
Totally insane.
Well, it's going to be pretty unique, kind of unique. Huh?
Yeah,
that's going to be very, yeah, exactly.
We're just like, they're like, we can't query this. We're like, I think we know why.
Yeah. So. And the point is, I mean, the point of this terrible example, and the data engineers understood that it was horrible, is that there needs to be more integration between data engineering teams that are consuming data and application teams that are creating data. They need to work almost as a single assembly line, right? But going back to Joe's lean process example, in the past, the way data warehousing worked is the data was generated, it was kind of put into a shipping container and sent over to the warehouse, and then you unpack it and you turn it into a star schema and all this stuff. And the key to live data is to make that one assembly line where the data is generated in the application, it flows into a streaming system, and then it flows into maybe an event-based processor. Yeah.
In manufacturing, it's a difference between an assembly line and single piece workflow, right? So,
exactly.
With single piece workflow, you just have a lot less room for error, because, well, you get a lot less defects if you do something like that.
Yeah.
Versus, sort of bunching everything up in batch and then hoping to God there's not a defect anywhere in that giant pile of stuff you just created. So it's very similar. It's interesting. What I find interesting as an aside is how many even DevOps, they got their inspiration from lean and supply chain, right? And manufacturing. This is what I find over and over again in data is we're basically, if you really want to understand where data is going, go and read supply chain books. They basically tells you all you need to know. Like the Goal, classic book. There's no shortage. The Toyota Way, I think, is a fantastic book. But if you look at what's happened in supply chain and manufacturing, it's literally no different than what we're trying to do in data right now. The practice of DevOps, it literally came from supply chain.
Yep.
So,
and I'll pile on top of that. When I was at Honeywell, I was supporting our oil and gas group, and they built process control software that sat on top of the equipment that they were selling to their customers. So it was all sensor based, heat exchangers and catalyst converters and all that kind of stuff. And I was trying to get them help with data engineers. So what we finally did is we gave their software team a handful of data engineers based on their product releases for the year. And then I sat through their planning and then watched them execute. And I was like, holy cow, this is a phenomenal process. It wasn't until I left that I stumbled down the Scaled Agile framework. So I took that certification, and in the first 20 minutes, I was like, holy crap, this is it. We got to apply these lean principles, including data ops. Well, it was DevOps and what it went through. But so we spent a lot of time adapting that Scaled Agile framework for analytics.
That's so cool.
I think it's a pretty good execution model for shortening our window and delivering our value faster.
Did you feel like you had a superpower?
I did. My shirt busted open and all sorts of stuff.
It is empowering though, because it's like being able to see behind walls, right?
Oh
like
gosh, yeah. And the power of those cross-functional agile teams, 6 people knocking out product every 2 weeks. That was great.
That's awesome. Yeah, I wish more people would do this. I mean, just this ability to see waste, right?
Yep.
That's a huge skill.
Yeah.
You can just walk into a situation like I can still walk into warehouses and I can be like, that's off, that needs to be fixed, right? Like instinctively. So and data stacks, I guess, too now. But
one thing I'll add with the transition from like DevOps into data ops is that it's important to see how they're similar, and it's important to understand why they're different. And this is where data observability comes in, because traditional data warehousing, what was the assumption? Well, the assumption was that the data was mostly your product. In other words, it was generated by internal business processes. It was mostly pretty constrained. Yes, there were data quality issues, but they were kind of mostly in your walls. Increasingly, we have clients who might have 100 or 200 external data sources. Not to mention that the web itself is an external data source. You've got bots generating traffic to your site. You've got all kinds of different devices hitting your site. And that's where we have to move into more of a statistical process of observability, saying, you know what, data is chaotic, data has entropy, and add that into DevOps processes.
Yeah, and the other similarity, because I heard many people, our colleagues, saying, oh, we can't do DevOps, we do data. I was like, oh my gosh, are you kidding me? Yeah. You're writing software to produce a product that comes out the back end, right? So that, again, just reinforced that whole mindset.
That's interesting.
Data products, yeah.
But yeah, why do you think it's so hard for people to make that connection though? Because data products, I mean, to people like us, it's just like, yeah, duh, that's what we make. So other people, it seems like a foreign concept. Like you're describing, I don't know, just like an alien technology.
Yeah. My one thought, Joe, is 25 years of ingrained art form that we served up. I mean, I was data architect for a long freaking time, and I thought I had it all figured out. Right? Yeah, but I don't know.
Well, I think you hit on something. Flexible thinking is, I think, definitely maybe a big theme too. Maybe number 4 would just be, just more of I think a need to be more flexible in your thinking, because things are changing so fast. Like the kind of work you think you're going to be doing isn't the work you probably will be doing. And that's just a general rule in technology in general. Like, who was it? Stuart Brand, famous writer and thinker in the technology space, but he had the concept of the steamroller of technology, right? Where if you're not on the steamroller, you're getting flattened by it. And that's, I think, really true. We put about a 2-year expiration date on any particular tech, for example, right? Like you always have to be ahead of it. But that also with architecture is an interesting one. Just because, again, I think to your point, you think you have it figured out until you don't. So,
right. Well, and I think I'm hoping more and more people really understand that we do not control some significant events taking place that impact us all.
Right.
So back to your point about flexibility and the lean principle, assume variability and preserve options continuously. You got to
For sure.
Even at the strategic plans for these enterprises.
Oh, that's more critical than ever.
You can't have a 5-year plan anymore.
There's no 5-year plan. There's not even, you tell me 2 weeks ago, 3 weeks ago, your 5-year plan just went out the window.
Not to mention COVID. I mean,
yeah, COVID threw everything out. But yeah, I mean, who would have thought we're, gas prices, oil the way it is, today? That was, nobody had that factored in,
Yeah.
I mean, maybe you did, but in hindsight, everyone says they will. Oh yeah, I did that. I modeled that for sure.
Yeah. I wonder if anybody factored in the barge shoving its bow into the side of the canal.
Right. Yeah.
Do you know how much?
It
was like $500 million an hour was being lost while that canal was closed.
Isn't that insane?
Yeah. 500 million an hour.
Man.
Oh, this is fascinating dialogue, gentlemen.
Likewise.
So you mentioned a book a couple times. When can we expect this bad boy?
It's actually available on pre-order on Amazon right now. It says October. So probably around there, hopefully sooner. Right. So I know our publisher's making us burn the midnight oil to get this thing done. So more about that. Yeah.
Do you have the cover queued up, Joe?
Oh, thank you.
The cover real quick.
I don't.
Oh, let me find it. I'll but in just a second.
But the link was just dropped for it.
Yeah, okay. I dropped it into the chat, the link to the book.
Yeah. So everybody go and subscribe to O'Reilly. Get it. Buy 50 copies for your team. So pre-order at full retail. That'd be great. Thank you.
I'll have to get myself a copy and then invite you guys back.
We'll sign it for you.
Series.
Yeah, we'll sign the PDF or the real one, whichever. So
yeah, there you go. I'll sign it on my iPad. Yeah. Michael, you're in Colorado, right?
I'm in Denver, or Dallas, rather.
Yeah. Oh, okay.
Yes. You're often in Denver.
I am often in Denver. Yes. Well, gentlemen, fascinating dialogue.
Yeah, thank you, everybody.
Really enjoyed the time with you guys today.
Thank you for
taking it with us.
This is great. Thank you guys so much.
Yeah, anytime.
So we have dropped the links into the chat for the book, for Ternary Data's site. Definitely check out YouTube to see their Monday morning data chat podcast. And then the final call to action is on the Great Data Mine side of the house. On this Thursday is our third annual Tech Matters Marathon. We are showcasing 6 amazing data-focused companies. So please check us out there. And I think that's all we got for you. This is a great conversation, guys.
Yeah, likewise. Thank you. Yeah, I had a lot of fun.
Joe,
it's always fun talking with Mike. Yeah.
Thank you.
Thanks, everybody. Yeah. Cool. Have a good day, guys.
Have a great day. Thanks.
Yeah, thanks to the audience. All right, see ya.
Thank you, everybody.